Those who were not there for the previous session can take down the rules once again if you want. Okay, these were the rules. Please go through it. As you can see, the first rule is always the first node or the event. Okay, there'll be only one and only initial event, and the tail, you can say terminal or the last event. There's only one, and all other nodes which are between this initial and the terminal node has to be tied up with all the other nodes. Okay, it cannot be, hanging nodes or nodes which do not have any events coming out of it. That is not possible when we are drawing the network diagram. The only two, you can say, the nodes which will do not have any incoming node or outgoing node will be your initial node and your terminal node respectively. Now, each activity in the network should be represented by one and only one arrow. You cannot have multiple arrows for the same activity. Neither no two or more activities can have the same tail and the head node. Now, if by chance you find that you are coming across something where some activity which is tend to have the same head and the same tail, then it indicates that you have to introduce your dummy activity so that we can take care of this problem. The fourth rule is the arrows should be straight and should not be crossed, okay, unless it is unavoidable. As I told you last time also, please try to avoid the arrows crossing each other. Okay, they should be straight, and it cannot be, zigzag or, rounded up and all. So in some cases, when you're drawing, it's bound to happen that you do not put a very straight line or something. That's fine, but it should not cross each other. Please remember this. If suppose it is avoidable, please avoid it. The next rule is that each event in a network is identified by a unique number. Okay, and the initial number always starts with 1. Okay. Now there is some rule which you need to follow while giving the numbers to the nodes. Okay, and Fulkerson rule is available, which can be taken or which can be used to give the numbers. Or you can also give the numbers as per your, you can say, intuition. But it's better to follow the rules. The first rule is that number the initial node as 1. That is very logical. Now, when we are giving the next number, okay, you are supposed to delete the outgoing arrows starting from this numbered node. That means if I have numbered the first node as 1, whatever arrows or whatever activities are going out of that particular node has to be hidden, or not deleted, you can say hidden, and then check whether there are nodes which do not have any arrows coming into it. So those nodes will be numbered first. Okay. Again, there can be a case where there are multiple nodes which do not have any activities or any arrows coming in. In that case, you follow from top to bottom rule. Okay. Always put the number of the topmost node as the next number. Okay, that rule you can follow. Clear? And the number, as I told you, it has to be consecutively given. The progressive logical order should be followed, like 1, 2, 3, 4, and so on. Do not have a reverse arrow or something. Like we go in a circle, we come backwards. Coming backwards is not suggested when you're drawing your network diagram. Now, to take an example, let us take one last example. And again, we need to follow this step number 2 and 3 again, repeat it again till we get the last number or till we put the number in the terminal node. Okay. Let us take an example. Now, draw a network for a project of erecting a storage steel shed for an industrial unit. The activities involved in the project are as follows. Now, this is just a network diagram. They have not given any duration and all. Okay, so there's no network analysis in this particular example. Okay, we are simply going to put the nodes and the arrows and connect the nodes to come up with a network diagram. If you want, you can give a try, and you can share your, you can say, network diagram by switching on your cameras and displaying it here if you want to. Or I'll just show you the first one. Let us start with the first one. These are the activities, the descriptions, and the immediate predecessor activity given to you. So based on which you have to create your network diagram. So we have the first activity as A, which says erect a site workshop. And because we do not have any predecessor activity, that means if you look at A and B, both do not have any predecessor activity. That means both of them are the initial activity, A and B. Next is your C, which is having an immediate predecessor as A. Then D, big foundation, having predecessor B. E for fabricate steel work, which is followed actually by, which is having a predecessor E for F. Now look at G. In case of G, where the place, the reinforcement, the preceding activities, there are two activities, C and D. Okay. So while drawing this activity, especially the ones where we have multiple, you can say, activities coming together in a node or merging in a particular node, you have to be careful there. Fine. Once if you have taken this down, let us go ahead, and if you want, you can rewrite this whole, you can say, table. Okay. So one way or one step is, if you want to follow it, what you can do is place the preceding activities before the given activities. Like this is my given activities here. So what you can do is you can put this column, okay, in front of the activity column. So wherever you see that there is a dash, you know that this is the beginning one. Okay. Right now it is just the reverse one. So I know our A is the preceding activity. So I need to have the A activity before we actually go for C. Okay. So if you want, you can do that. Predecessor activity can be put, and the given activity can be put in the second column. That's very much possible. Let us see how to draw it. Okay. My first activity, I'll put one node. Okay. I'll number it. Now, because I have directly numbered it here, for you, it will be easier right now. What you can do is I'll show you at the end how to give the numbers as well. How I gave the numbers will be clear at the end. Okay. Now, as you can see, there are two activities, activity A and B, which do not have any predecessor. There'll be two arrows which will be coming out of this particular node. So I'll have one arrow with A, that's my first activity, and one more where we have B. Okay. So this will be my two activities, and as it is the beginning of my whole project, and there are no previous activities, this is how it will look. Now, the next activity is activity C, and the preceding activity is A. That means out of 2 here. Okay, so there will be an arrow which will come out of this. Okay, so one arrow from here, and the next one, that is D, is coming out of B. So there will be one arrow which will come out of here. Okay, so let us see that. So here we have one C, and here we have a D. Now, why we have merged C and D is because if you look at activity G, okay, we have an activity C and D coming together. Okay, so the immediate preceding activity CD is merging together. That indicates that there will be one node where the arrows are going to merge, and these two activities has to be, you know, say merging into this particular node. The number, as I told you, the number will be given by me later on. I'll show you what is the logic of giving the numbers. Okay, so C and D is merging together. E will come out of again A. So from 2 here, I can have another arrow E. Okay, and we do not have any you can say merging here, so I can just put the circle here. So I have E here. Then for F, it is going to come out of say B. The preceding activity is B here. So an arrow from 3 will come out. I have a circle here. Okay. Now this F and G will be together. So you can see I have put them together and it is merging into one node. Clear? After G we have H, and H have the preceding activity G and F. That means it is going to come out of 6. So we'll have one arrow coming out of 6. We can name that as H. Okay. Next we have I. The preceding activity is E. And if you look at H and I is going to merge together. So 4 and 7 will get connected here. So I can connect 4 and 7 and name this as I. And finally, we have J, which will come out of 7 because J has the preceding activity H and I. So here I have J, and the last one will be K, which is giving finishing touch, which will be coming out of 8, and we have this last node 9. Okay, so this will complete my network diagram. Now to just explain you how I gave the numbers. Okay, as I told you, you have to start with this first node, give the number 1 here. Okay, then hide this arrows which are coming out of this node. So there are 2 arrows which are coming out of this node. So this one and this. So once we hide this 2, there are this node and this node which do not have any arrows coming in. And because there is a tie between these 2 nodes, both of the nodes do not have any arrows coming in, I can give the topmost node as number 2. Okay. Or you can also think about giving it, because we have alphabetical order, E is first. So I give this 2. Okay. 2 and 3 will be given. Once we give 2 and 3, I have to hide all the arrows which are coming out of these 2 nodes. So this 2 arrows plus these 2 arrows will be hidden. Okay. Now once I hide this, okay, I have one node here, or let us take I hide this one, this 2. Okay. Once I hide this 2, because I am not going to do this first, I'll hide these 2 arrows. I'll find that this node do not have any arrow coming in, whereas this node has one arrow coming from this 3. Okay, and that's the reason I did not give this number as 4. I gave 4 here. Is this clear? Once we have given this number 4, okay, and there's no more node which is not having any arrows coming in, then you hide the arrows from this node 3. Okay, so hide these 2 arrows, which is for D and F. So in that case, what happens? This one will not have any arrows coming in because we are considering this is to be hidden here. So 5 will come here. Clear? Now when we hide the next one, so hide this one, this arrow, there's one arrow coming out of this. So I'm hiding this one. Okay. So 4, 5, and this is already 2 hidden. So we can give this number as 6. Okay. And this is given 7 because if I hide this one, there's still an arrow which is coming from here. And that's the reason we have given 6 here. And then 7. And this is very simple. It's in straight line. So you keep on giving the next numbers here. Okay. So there was a complication here where we gave 4 here and 5 came here. That was just because there was one arrow which was still coming to this particular node, whereas this node did not have any arrow coming in. And that's why this node got the number 4 first. Is this clear, everyone? If you have doubts, you can ask me any questions here. Else, we can go ahead and look at how to do network analysis. Any doubts here?
No, sir.
I need some answer from you all.
No, sir.
Okay, there's something in the chat. Harshil, no. Okay, Harshil is the only one who's active right now, I think. Okay, let us go ahead and try to understand how to do network analysis. Okay, few more. Great. Let us go ahead. Okay, once we complete, actually, this one is just a simple example of drawing a network diagram. This is not the only thing which we need to do. Whenever we are drawing a network diagram, all your activities, events, will come along with some time duration. And especially in case of CPM, there'll be a single time duration or estimate which will be given to you. Because as I told you at the beginning, CPM is deterministic. That means the time for a particular event or activity is already known. Whereas in case of PERT, okay, we make use of three time estimates to determine the time duration. Okay, so in that case, we need to do some calculations while getting the time duration for a particular activity. Okay, so before we move ahead, please remember the concept of numbering is very important. If you number it wrongly, you get a zero directly. Please remember this. Okay, so please rehearse this concept of giving the number. Let us go to the next topic of network analysis. Now, after we draw the network diagram, okay, and on getting the estimates of the time duration, and as I told you, the time duration for CPM is based on only one fixed value. Okay, a value will be given to you, which is unique value. Whereas in case of PERT, we need to use the three time estimates to find the duration. Okay, so once we get the time, now in the previous example, the time duration was not given to us. What we will do is we'll take one example in the next slide and see how to do the estimation. Okay. So after the network diagram is drawn and on getting the estimates of time duration for all the activities, we can analyze the network in order to get some values. Now, what is that? There are some notations for that. So the analysis can happen based on some schedule, the performance of the activities. Secondly, estimation of the duration of completion of the project, two things. The third one is identifying the critical activities. Once we find, and this is especially in case of CPM, once we get the network diagram along with all the early starts and the latest starts and finishes, we can find out the critical activities. And fourth one is find out the flexibility in scheduling the activities. Now, the last topic is very important. It contains all your probability, distributions, concepts which we have learned before. Okay. We are also going to see how to make calculations of your slacks and floats as well. Okay. So that is going to help me, scheduling my activity. So if there is a zero float or zero slack, you can say, for a particular activity, that means that activity should start in time. If it does not start in time, the overall project will get delayed. Whereas an activity which is having some slack of say 1 or 2, depending on, let us say days, 1 or 2 days, that means that activity can be delayed by that period. If it is 1, that means 1 day. That means the activity can be delayed by 1 day. Okay, and this is not going to impact my overall performance or overall completion of the project. That is what we will be finding out in the last one, this one, flexibility in scheduling the activities. Okay, now to do all this, there are some notations which are available, which we should be aware of. So Oh, one more thing, please remember, we are going to only do analyze only the time and not the cost. Whereas if you want, even a cost can be analyzed. But as per the syllabus, we are going to only consider time duration for the activities, right? Let us consider a network diagram. I want you all to draw this network diagram and not take a picture of this. It's along with the time duration of the activities, which are given in a bracket next to the activity, and it looks like this. So this is my network diagram. Activity A, the duration is 2, and let us consider this to be in days. Okay, and if you look at there's one dotted arrow, which is between 5 and J. H, this is my dummy activity. Okay, and as it is a dummy activity, please remember, if you were there for the previous session, I told you dummy activities will have 0 duration and it won't impact the overall performance or schedule of my project. Okay, it's just because you can see your F and G might be having the same tail and the same head merging in 4 and 6. Now that is not possible to put, this arrow, this one, for activity G. I cannot put an arrow between 4 and 6 directly. That's the reason we have created this dummy activity here, so that I do not put this arrow here, which will be wrong if you do that. If I have two arrows coming out of the same node and merging in the same node, which is not allowed as per the rule. Okay. So please draw this diagram, because in this diagram only I'll be showing you how to find out the EST and the EFT, that is your early start time and your early finish time. Okay, earliest finish time. Fine. And in the same diagram, again, we'll take it up and we'll try to determine the LST and the LFT, which is your latest start time and the latest finish time. Okay, this will give me an overall picture. So this picture or your network diagram has to be drawn on a piece of paper, please. I'll give you some time to draw it. Okay, let's go ahead. Now there are some notation, as I told you, which we should be aware of. Please note down each of them. So the time analysis of our network requires determination of the earliest and the latest time for starting and finishing the activity. And for this, we are going to make use of some notations. So please note down these notations. Wherever we say I, comma J, I will be the tail node, J will be the head node. Okay, or you can also call it as an event. Then EI represents the earliest occurrence time of event I. LI is the latest occurrence time of event I. Then TIJ is the time duration estimate of the activity IJ. Now ESIJ, that is your earliest starting time for activity I, comma J. Similarly, we have EF, that is your EFIJ, earliest finishing time for activity I and J. LS and LF will be your latest starting time and latest finishing time for activity IJ. Now, all this has to be calculated without affecting your overall project calculations. Okay, you cannot manipulate this. It has to be calculated in a very systematic way. Now, what are the formulas for this? Very basic formulas. It's just about addition and subtraction. Please note down each of them. There are two concepts here. Whenever we are supposed to find out ES and EF, we are going to determine it by using the forward pass calculation. There are two things, forward pass and backward pass, using which we can do the calculation. Okay, so let us see that first. The first one, as I said, forward pass calculation, which will help me find the values of EST and EFT. The first formula, always your earliest occurrence time for the initial node, my first node, will be always 0. Okay, so E1, if I represent that as earliest occurrence time of event 1, will be always equal to 0. Okay, please remember this. So the first one, we assume the earliest occurrence time for the initial node, okay, or event as 0. E1 will be considered as 0. Please remember. Using this value, I can find out the earliest starting time for say ESIJ. So ESIJ will be nothing but equal to EI. That is 0. Okay. So the first activity, if it is the first activity, say activity 1 and 2. Okay. So the early start ES 1, 2 will be equal to 0. Okay. This 0 plus the time duration for activity 1, 2. Let us say if the time activity is say 5. So 0 plus 5 will give me the EF value. EF for 1, 2. Okay. The earliest finishing time. Yeah. So if you want, you just note down these formulas. So for your early starting time will be same as EI. So ESIJ is equal to EI. Please remember this. Secondly, the earliest finishing time is obtained by adding the duration, that is Tij, to its earliest starting time. Now, if this is the first node or first activity, as I told you, if this is 1 year, this will be E1, that is 0 plus Tij. Okay, so EFIJ is equal to EI plus Tij, or you can also make use of the early start of the event plus Tij. But because this is same as EI, we can also use EI plus Tij. Secondly, if there are more than, you can say, 2 arrows, merging in a particular, you can say, node. Okay. So for a head event, let us say J of an activity, the earliest occurrence time, that is EJ, is given by the maximum among the earliest finishing time. If there are 2 arrows coming in, that means they are finishing at 2 different periods. Let us say one is finishing after 4 days and the other one is after 6 days. Okay, the maximum is 6. Okay, between these 2. So this maximum will be the earliest occurrence time for your next event. Okay, so we have to find out. So EJ will be equal to max of your EFs IJ. Okay, clear? Now for this, I'll show you an example. When we take the same diagram which we have drawn in the previous slide, I gave you that network diagram. We are going to do that, this calculations on that particular diagram. I hope you have taken this down or you have understood this. If you don't, if you have not understood this, when I explain you in the diagram, it will be very much clear. The second pass is your backward pass, and it is used to find out the values of LST and your LFTs. Okay, backward means we go to the last node, and from the last node we move backwards. We move to the first node, towards the first node. Okay, and the last node will have some value, that finishing time or the EFT. The EFT of the last node will be the you can say LFT of the last node. Okay, so we begin with the occurrence time of the terminal node, and if we take that to be a capital N, then we proceed in the backward direction to calculate the latest finishing and the starting time of all the activities one by one. Now this also yields the latest, you can say, expected occurrence time, your Li and Lj, for each event in the network. We assume the last or the latest occurrence time for the terminal node or the event, let us take that as Ln, as equal to the earliest occurrence time, En, as found at the end of the forward pass calculation done before. So Ln will be same as En. Okay. And for the other activities, the latest finishing time, because we are going backwards, we have to calculate the finishing time first, is the latest occurrence time, okay, Li, of its head event. So Lfij is given by Li. And the latest starting time is obtained by subtracting its duration, because we are going backwards, we have to subtract, okay, from its latest finishing time, Lf. So Lsij can be given by Lfij minus Tij. Or you can also put it as Lsij equal to Li minus Tij. And the last one, when we are going backwards, like in forward pass, we found out the maximum of the two values where there is a merge happening. Now here we'll be having when we go backwards, the minimum among the latest starting time will be considered here for the tail event I. Okay, so Li is actually given by minimum of Lsij. Let us take that example. Now you draw this diagram. Now I have just done the forward pass, and I want you all to do the backward pass. Now look at the values. Pay attention here, because this is more important when you're doing the network analysis. Now, as I told you, the first node, this is my first node. 1, 2, okay? It's going to start with 0. So this is my E1. Okay? So 0 plus 2 will give me the EF of 1, 2. EF 1, 2. Okay? And that's why we get 2 here. We have to write it here. Then the starting for 2, 3, event 2, 3, activity 2, 3. This will start, the tail will have 2 here, because that's the finishing for this. So this 2 will be same here. And even this will start after, if I consider this to be in days, then this is going to start in after 2 days, and this also after 2 days. That means once this activity A is completed. 2 plus 3 gives me 5. And here 2 plus 4, now this is wrong here. 2 plus 4 will give me 6 here. Okay, let me do this again. 2 plus 4 will give me 6. So this is 6 here. Okay. Now 2 plus 3 gave me 5, and that's the reason I got 5 and 5 here. Okay. 2 plus 4 gave me 6. This is also 6. So there's a tie between this. I need not find the maximum, as it is the same. This 2 event, that is F and G, is also starting at 6. So this is the ES of 4, 6 will be equal to 6. 6 plus 3 gives me 9. 6 plus 2 gives me 8 here. Okay. Whereas 5 plus 1, 5 plus 5 is giving you 10 here. Now in this case, here I have 10 and here I have 9. Now here we have a dummy activity H here. Now this is going to start at 8, and this is 0, so this remains 8 here. Now there are 3 values which are merging in, 3 arrows which are merging in the node 6, which is having value 10, 9, and 8. The maximum is 10. So I will commence on the 10th day. So I give the ES of 6, 7 as 10. 10 plus 2 gives you 12. And that's my EF of 6, 7. Okay, let me play this again. So slide from the current show. So your network diagram looks like this once I complete my forward pass. Now, what about the backward pass? Backward pass will start from node number 7, from here. Okay, and I'll put the number here. So if I have to put the number here, let me put it here. I'll copy this whole thing. So this will be 12 here. Okay. This will be 12. 12 minus 2 will give me 10. So here again, I'll get 10. Fine. Now, because this is the, you can say, after performing the subtraction. Okay, once we perform the subtraction, that is 12 minus 2, I'm getting 10. That is nothing but your LSIJ. Your I is 6 here and J is 7. Okay, now this 10 will come here, here, and here. Okay, so all these three arrows below this, I'll have 10. So if I keep 10 here, 10 minus 5 is going to give me 5 here. Okay, let me display this. So if this is 10, here I'll get 10, 10, and 10 here. 10 minus 0 will give me 10 here. Okay, because H does not have any division. Whereas यहाँ पे, in this case, if I have 10 here, 10 minus 3 will give me 7. So this will be 7 down here. And on top, we have 6, 6 and 7 here. And here we're going to have 5 here. Okay, now here we have, say, 10 minus 3, that is 7. Whereas in this case here, 8. So this was 10. This is also 10. 10 minus 2 gives me 8 here. So this is 8. This is 7. Okay, which is the minimum one? 7. So this will be 7 here. So I'll have 7 here. Clear? So please do the calculation for the backward pass and show me the answers. Going backwards, please remember whenever there is multiple arrows coming out of it or going out of that or merging into it, please remember the minimum thing, especially when we are going backwards. When we are going forwards, it has to be the maximum among all of them, which are merging in one node. And while coming backwards, we have to consider the minimum value. Anyone who's done it can switch on. I'll just stop this presentation. Stop the share. I want, if you have done it, anyone who's done it,